When we think of stars, we often picture tiny, shiny spots in the night sky. From here on Earth, this is how we perceive them. But stars like Betelgeuse are another matter together. Betelgeuse, one of the biggest stars, is actually substantially bigger than our Sun. This star has long baffled scientists, but more recently, Betelgeuse has begun exhibiting increasingly unsettling behavior, which has astronomers and scientists quite concerned. Join us for this conversation as we explore the recent and dramatic news regarding Betelgeuse and its impending annihilation, as foreseen by the James Webb Space Telescope, and the potential implications for our galaxy and our life on Earth. Betelgeuse is an endless marvel, a massive star that has long enchanted cosmologists. It was first discovered by Antonia, a Greek astronomer. Because of its immense size, this star can be seen in Earth's evening sky, particularly in the winter. This rosy-orange star, which denotes the upper left shoulder of the constellation Orion, is probably something you've seen or heard about if you're interested in astronomy. Betelgeuse is one of the oldest and brightest stars in the night sky at the moment. But one aspect of Betelgeuse's genius is that it fluctuates rather than staying constant. Its star has a number of intriguing characteristics, its volatility being only one of them. Let's examine a few of Betelgeuse's unique qualities. The closest star to Earth is 4.2 light-years away, and the majority of the stars seen in the nighttime sky are far from us. If the concept of a light year and distance are unfamiliar to you, visualize traveling at the speed of light for a full year. The speed of light is roughly 186,000 miles per second. As a result, 1 light year is the amount of distance that light can travel in a year. That's billions of miles in total. Therefore, the closest star is billions of miles away from Earth, while it is said to be 4.2 light-years away. Betelgeuse is one of the stars that is even more away, though. You may find Betelgeuse about 600 light-years away from Earth. It would still take 600 years to get there even if you traveled at the speed of light. Not even our fastest spacecraft can travel that fast. It is still possible for this star to shine so brilliantly in our sky. If you're wondering how Betelgeuse manages to remain so brilliant at such a distance, it's because of its distinct qualities, such as size and brightness. Betelgeuse's radius is thought to be many times that of the Sun, and it is around 500 times larger than the Sun. Unfortunately, with sophisticated telescopes, it appears as a disk in space, whereas other stars are tiny dots of light. It is believed that the reactions occurring at the outer layers of its atmosphere are what caused its disappearance. Betelgeuse has a mass of between 12 and 19 solar masses. Astronomers use the standard unit of mass, the solar mass, which is roughly /2 times 10^30 kg. Since there are no other planetary bodies around Betelgeuse for comparison, and since we can't determine its exact mass directly from here, scientists are unable to come to a consensus on its exact mass. This star is remarkable since it is several times heavier than our Sun. Betelgeuse's brightness varies from magnitude +0 to +1.6. To put it more realistically, Betelgeuse has 16,000 times the luminosity of the Sun. That's why it went by the moniker Red Giant. But Betelgeuse's brightness changes. It never stays constant. The reason for this variation in brightness is because Betelgeuse pulses, or expands and contracts. It gets brighter when it expands and gets darker when it contracts. 10 to 100 days, or possibly longer, may pass during this procedure. Betelgeuse's surface is covered in dark magnetic patches, which is one of its distinctive characteristics. Compared to the typical surface, the magnetic field is much stronger in these places. The drawback is that the star cools off in these areas because the hot gas cannot move as freely to the star's outer surface due to these strong magnetic patches. Betelgeuse is colder than our Sun despite its size and brightness because it has a greater number of these spots than our Sun. There are black magnetic patches on the Sun as well, but Betelgeuse has more larger and more numerous ones. The spots on Betelgeuse can measure up to double the size of Earth, just to give you an idea. In addition, Betelgeuse has a magnetic field 1,000 times stronger than the Sun's. This field explains why the gases on Betelgeuse's surface appear to be arranged in spirals or arcs when observed through a telescope. The surface temperature of Betelgeuse is approximately 3,500 Kelvin. The star's low energy and weak red color are caused by this low temperature. Although Betelgeuse is a red star today, it was formerly yellowish, similar to our Sun, some 100,000 years ago. Its hue gradually changed over time to an orange-red, and about 10,000 years ago it began to gradually transform into the red star we are familiar with today. Because of this fact, scientists think that the star is getting older. Up to 10,000 times as much energy is released by Betelgeuse as the Sun does. If it hadn't been so far away, it would have been a serious rival to the Sun of Earth. It's also really amazing that Betelgeuse, which is 600 light-years away, can still be viewed and recognized at night with the unaided eye. Our Sun is extremely powerful since it is only 8.3 light-minutes away from Earth. We would also be able to view Betelgeuse throughout the day if it were a bit closer. But because of its massive size, it would devour or displace Earth and the other 4 surrounding planets if it were to replace the Sun. Furthermore, it still emits more radiation even if it could equal the Sun's energy output. Located approximately 600 light-years away from Earth in the constellation Orion, this huge star is also referred to as Betelgeuse. One of its most remarkable characteristics is its sheer enormity. At 500 times the radius of our Sun, it could easily encircle Jupiter's orbit if it were positioned at the center of our solar system. When observed through large telescopes, Betelgeuse's enormous size makes it appear as a visible disk rather than a point of light. Betelgeuse is not the most massive star, in contrast to the majority of stars. Estimations place its mass between 12 and 19 times that of the Sun. Betelgeuse's fluctuating brilliance is one of its most intriguing features. In contrast to our Sun, which experiences erratic swings in brightness throughout time, Betelgeuse has very steady brightness oscillations. These oscillations are thought to be the result of the star's internal processes pulsing. Betelgeuse can shine 16,000 times brighter than the Sun when it reaches its peak brightness. Nonetheless, there may be noticeable drops in brightness during dimming periods. Astronomers have been studying these oscillations in great detail. These alterations have been seen across centuries, offering important new information about the physical characteristics and life cycle of the star. For a star of its size, Betelgeuse's surface temperature is comparatively low, at about 3,500 Kelvin. It has a characteristic reddish-orange color, which is attributed to red giant stars nearing the conclusion of their life cycle. Betelgeuse is a late-stage star that has started fusing heavier elements after burning up all of the hydrogen fuel in its core. The star is pushed outward by the energy produced by this fusion process. The star's atmosphere is full of intricate physical phenomena. On its surface, dark magnetic patches can be seen that are far bigger than those on our Sun. These spots are areas of high magnetic activity that prevent hot gases from rising to the surface of the star, resulting in colder areas of the star. Several civilizations have been aware of and observing Betelgeuse for ages. Ancient astronomers from many cultures, such as the Greeks, Egyptians, and Chinese, noticed its brilliance and color in addition to noting its position. Yad al-Jawza, or the Hand of Orion, was the name given to Betelgeuse in ancient Arabic cosmology, indicating its significance in the constellation. Many mythology and cultural allusions have been influenced by its visibility and unpredictability over history. The dimming episodes of Betelgeuse, which started in late 2019 and lasted until mid-2021, have drawn more scientific interest in recent years. The star's brightness fell to previously unheard-of levels throughout these times, leading astronomers to conjecture about its future. Several of the most talked-about theories speculate that Betelgeuse might experience a supernova soon. Explosive occurrences known as supernovae happen when large stars run out of nuclear fuel and collapse due to gravity. Betelgeuse would unleash a massive amount of energy if it went supernova, making it one of the brightest objects in the night sky that might be seen during the day. Because of Betelgeuse's closeness and visibility, there has been significant curiosity from the scientific community on its prospective supernova. Using telescopes and space-based observatories, astronomers are still keeping a careful eye on the star in order to collect information on its behavior and evolution. Because of its red supergiant state, Betelgeuse offers important insights into the final phases of star evolution, such as the fusion of heavier elements and the ultimate distribution of these components into the interstellar medium from the star's core. In conclusion, Betelgeuse is a fascinating topic for current and upcoming research due to its unpredictability, historical relevance, and possibility for a supernova. Astronomers can gain a deeper understanding of cosmic dynamics, stellar evolution, and the intricate processes forming our universe by examining Betelgeuse. Most of us perceive stars as tiny, far-off, glittering points of light when we gaze up at the night sky. But we're not just talking about small spots of light when we talk about stars like Betelgeuse. This star, which is a member of the Orion constellation, is among the biggest and most well-known stars that can be seen from Earth. Its history is replete with cosmic drama. Red supergiant Betelgeuse is a massive star that is around 600 light-years away from Earth. We can infer from this classification that it is nearing the end of its stellar life cycle. The star's immense size is beyond our comprehension, yet its diameter is thought to be about 500 times greater than that of the Sun. To put this into perspective, picture Betelgeuse at the center of our solar system. It would dwarf our Sun and extend beyond Jupiter's orbit. Betelgeuse is a huge planet, yet its brightness varies a lot. At its brightest, it has almost 16,000 times the luminosity of the Sun. But occasionally, the star dims significantly, sparking debates in science and a great deal of conjecture in the general public. The most notable manifestation of this dimming occurred in late 2019, which sparked curiosity and interest about what might come next. Is it about to explode like a supernova? The behavior of Betelgeuse has long captivated astronomers and astrophysicists. The remarkable fading that took place over several months in 2019 and 2020 made Betelgeuse one of the dimmest stars in Orion for the first time ever documented. It turns out that the reason for the star's weakening wasn't as straightforward as it seemed, even if this raised hopes that the star was on the verge of going supernova, a tremendous explosion that happens when a star runs out of fuel. According to recent studies, a dust cloud that gathered around the star is most likely what caused the star to dim. Betelgeuse is continuously releasing material into space, and occasionally, significant amounts of this material may gather into dust clumps. This cloud of dust hid the star from our perspective, making Betelgeuse appear much fainter than usual. The star itself is still very much alive, even though this cloud of dust may have momentarily reduced its brightness. There is also no concrete proof that the star is about to blow up. We must examine the life cycle of Betelgeuse in order to completely comprehend its significance. Betelgeuse was formed from a massive molecular cloud of gas and dust, just like all stars. Like our Sun today, it has been fusing hydrogen into helium for the most of its existence. But Betelgeuse is far larger than our Sun. Its core is no longer filled with hydrogen, and it is already fusing helium with heavier elements like carbon and oxygen. The star has grown into a red supergiant because this process releases even more energy, which leads to the star's tremendous expansion. Betelgeuse and other stars die as violent supernovae. Betelgeuse will collapse inward due to gravity when its core can no longer support fusion. A huge explosion that briefly outshines the entire galaxy will be caused by this collapse. Despite being 600 light-years away from Earth, Betelgeuse would be visible during the day if it were to go supernova. This kind of outburst is a breathtaking sight, releasing components into space that enrich the interstellar medium and may even help generate new stars and planets, like oxygen, calcium, and iron. The elements that comprise the planets, including Earth, were created mostly from supernovae and their remnants. The star's core may collapse into a neutron star or, if it is massive enough, form a black hole, while the outer layers of the star are blasted into space following a supernova. Because of its size, Betelgeuse has the potential to explode and leave behind a neutron star, which is a dense remnant of its core. Even while Betelgeuse's ultimate supernova would be a beautiful sight, there's no need to panic because we won't be around to see it happen. It's likely to occur within the next 100,000 years. The distance between Betelgeuse and Earth is so great that even if it exploded tomorrow, it wouldn't endanger our world.